Okay, I've put on the subtitles today, so hopefully this will make a good demonstration. The three broad phases of design in object-oriented programming are: identify the objects that make up the system, identify how they relate to each other, and design how these may be implemented in the object-oriented programming language. We're going to look further at this today, and we're also going to touch upon UML class diagrams and UML case diagrams. Identify the objects. Each object must be separately identified along with its methods and properties, sometimes collectively known as objects' responsibilities. Identify the relationship between objects. Identifying the classes and subclasses from which they may be derived and how different objects will interact. Consider how each class and subclasses may be implemented into the chosen OOP environment, and for us that will be using Python. From existing classes within the environment or by creating new classes. The Unified Modeling Language, UML, is a widely used design framework for creating object-oriented programs. It is largely a graphical technique using some of the 9 different diagrams to represent different aspects of design. The Unified Modeling Language, UML, is made up of 9 types of diagrams: class, object, use case, sequence, collaboration, activity, state chart, development, or deployment I should say, component. We're only going to look at class and use case in Advanced Higher. The class diagram is used to visualize the different classes and their subclasses, their properties and their methods, and how they relate to each other. It provides the basic structure for an object-oriented program, and that's why we've already seen it. We've already used class diagrams to represent object-oriented programs, so hopefully these will be familiar to you. So we have the class name, properties, and methods. Let's look at these in detail. Class name. By convention, class names always start with a capital letter. The class name follows the usual naming rules, must start with a letter, and may include numerals and the underline character, but no spaces or other non-alphanumeric characters. The properties of the class. A list of variable names and their data types. These may be simple variables or data structures such as arrays, records, and objects. Properties may be encapsulated, as we've seen before, meaning their values can only be accessed, changed, using the class methods. And here they are, the class methods now. There are 2 types of class methods. Constructor. This is called only once, when an object is instantiated from the class. It assigns the initial value to the properties. And the mutator methods. These operate on the object's properties to read, assign, or change them. A bit more detail about mutator. Some mutator methods may be a setter, to assign a new value to a property passed to it from outside the object, or a getter, to pass the value of an object's property to outside the variable. And then mutator, to mutate the values of an object's property. Let's look at inheritance again. So this is mostly just revision for you. So inheritance is a fundamental principle of OOP design. It is used to identify the relationships between different classes. It is not efficient to create different classes for every object. Many objects will share characteristics and so could be said to have a common ancestor. Instead, superclasses are identified from subclasses and they're derived. So let's look at this. This is a class diagram showing inheritance. We have a superclass, the properties and the methods. And then we have subclass, additional properties, and extra alternative methods. And on the same, it's just the same on the other side. Inheritance, again. So subclasses only need to show the differences, the additional or modified properties or methods that are relevant to or specific to the subclass. Subclasses automatically inherit all the properties of the methods of the superclass. A method in a subclass can also be used to replace the original one in the superclass. It is said to override the original method. Class diagrams may be extended to show other classes and how they are related, like an entity relationship diagram, as we've seen with database. So here we have a larger diagram showing relationships. So we have the superclass, the subclass, and another subclass, and then we have another subclass which is also related. Okay, so the subclass has the properties and methods, and they inherit anything from the superclass, but not the other class over here. So class diagrams are often referred to as static. They are diagrams as they only indicate the objects, not how a user will interact with them. The use case diagram is used to illustrate how an external influence, i.e. a human, a machine, or another program, might interact with the system, and is therefore referred to as dynamic. Let's have a look at that now. So we have the use case diagram. This is where you put your title. The use cases, which is the superclass and the subclass. You have your extend and extend here. This is the extending of the relationship out to the new subclasses. And you've got your class, which is different. Okay, and this is the system boundary. Your actor here is the influence that it uses the program or whatever application you're running. Let's have a look at this. So both the class diagrams and the use case diagram are used at the early, higher levels of the design progress. When the big picture is drawn up and to get an overall view of the problem. The use case diagram uses to describe different elements and their functions that will make up a system and to show where different elements will interact. The use case diagram, however, is useful when drawing up the system requirements, and in particular how external influences will interact with it. These are the actors. Here's an example. So consider the game of drafts. If you've not played it, it's a good game to do in programming. This one is made up of a game board, red counters and black counters, each of which may be represented as a class. The game board class diagram would be title, you've got your game board with the properties, here they are here, and your methods, constructor and play. The red counter class diagram, you got your title, red counter, more properties and methods. What do you think the black counter is going to look like? So it looks fairly similar, doesn't it? So you've got your title, your properties, and your constructor, move and double, same as red. It should be obvious that the red and black counters are not separate classes, but instances of the same class. Counter, so we can call that counter, and it's got the properties and the constructor, move and double, but this time we're changing the color. Now compare the game board class and the counter class. Game board, counter. Can you see some similarities? You've got the top left X and Y coordinate are the same, width is the same, color is different, and the double status is different, but the constructors there, move and double and play are different. They have much in common though, so can be derived from a common superclass. So here we have the game. We have top left X coordinate integer, top left Y coordinate integer, the width integer, and the fill color RGB, and then the constructor. The board and the counter are the subclasses. You've got the different things for the board and the different parts for the counter. So notes, the constructor method for the board will create the 8x8 board using the alternative colors specified in the fill color and fill color 2. and place the counters in their initial positions. This will override the superclass constructor method. The play method for the board handles the actual playing of the game. The constructor method for the counter will create a round counter using the color specified in full color, set double to false. This will also override the superclass constructor method. The moon method changes the position of the counter on the board according to the rules of drafts, jumping over an opponent's counter to take it if necessary. Taking counters are moved to the side of the board. The double method simply records if a counter has reached the opponent's side of the board where double status is set to true and can now move forwards and backwards. Use case diagram. So here we've got the whole diagram that we can have a look at. So you've got the superclass, which is the game chess, extends to the board subclass, which extends to this counter subclass. Here's your player 1 going to start the game. Player 2 is joining in. This also works if you have an AI player and your human player, so they both work together. Moving over to what I want you to do today. I've got this document here, so let's just scroll back to the top. This document here has a lot of information in it about object-oriented programming, but it's got a lot of information still about use case diagrams and class diagrams, which we want to focus on today. There's some questions in it as well, which I want you to answer. You can have a look at the background and everything here. There's a cool diagram which basically shows inheritance in the dogs. Yeah, so you've got domestic dogs, you've got your larger dog and your small dog, all the way back to organisms, which is all living things. So I highly encourage you to read over this and have a look at it. Here are the principles, some which we've already focused on. Well, we've done all these actually, but it's important that you recognize that they are needed to be talking about the UML diagrams. So the design process, it goes into through the phases again, talks about which ones we're going to do, class diagram, use case diagram, and you can have a look at tutorials. Class diagram, here is another example. This is a worked example similar to the ones we just saw in drafts, so I highly encourage you to look at this. And then you have another one here for the use case diagram further down, I hope. No, we're still on the class diagrams. So what I want you to do for the class diagrams is read over these questions, okay, and do these exercises. So the exercises I would like you to tackle today are, you're creating a table tennis game. The game is made up of table, bat, ball, and scores. Make up class diagrams for this game. And then you've got a similar here, and it gives you some information. So battleships, and then you've got one for Tetris. I would like you to try these out, please. So click class diagrams for them. So remember, class diagram is this sort of diagram here, where it has the title, and then your attributes and methods. Okay. And then you can go on to talk about the use case diagrams, and it goes further into the pet and vet actor here as you're going to be using it in a pet system. And then you're going to change your things here. So drop use case diagram for table tennis, one for battleships, and one for Tetris. So you're expanding in the other questions above. Okay. So I'd like you to do these for me. So both these exercises. So one's for the class diagrams, and one's for the use case diagrams. Great. Any questions, let me know. You can just send me a message on Teams.